Write the rate equation for the reaction. We can recall that our rate equation is this. You notice that the reactants are on negative, but the product side are both positive. Before we begin, what we need to do is make sure this equation is balanced, which it is not. So I'm going to go ahead and balance that. You can always check what you're balancing by simply writing out each item that you have. You have N, H, Cu, and O. Then we count how many N's we have on each side. Over here we have 2. Over here we have 2. So we had 2 on the left and we have 2 on the right. For hydrogen, we have 2 times 3 is 6 on the left. And on the right, 2 times 3 is 6. For copper, we have 3. And on this side, we have 3. And our oxygens, we have 3. And on this side, we have 3. So now that we know this all balances, we can go ahead and start writing our rate equation. So we're going to say our rate equals, this will be our A, this will be our B, this will be C, and this will be our D. This one doesn't have anything in front of it, so we're going to kind of push it to the side for a bit. So we can say that our rate is negative, because it's on the reactant side, 1 change in the concentration of NH3 divided by 2 delta T, which equals negative 1 change in the concentration of CuO divided by 3 delta T equals, now we're positive because we're on the product side, so 1, no negative, over 3 change in the concentration of Cu over delta T equals, the reason why we're not using this one is because there's no coefficient before here, it's just an understood 1. And so it would read 1, which it would be positive because it's on the product side, over 1. And we don't really need to say that because it's just 1. So back over here, we still need our D. It's positive 1 over 3 delta T. And on top we have change in concentration of water. And that is how you write your rate equation.